Okay guys, so our last section for today is going to focus on complex expressions, and I know we've already seen a little bit of that when we were solving for zeros. We're going to mostly look at simplifying and then looking at zeros that have imaginary roots. So here we're just simplifying. I'm going to see if I can go through these really quickly. Notice we're subtracting one complex expression from another. So I have a negative 2 plus 3i. Because I'm subtracting this, I'm subtracting a 4, I'm distributing this negative, so I'm really adding 2i. So if I simplify that, that's going to give me a negative 6 plus 5i. So that's just a simplified expression. I just was subtracting one complex number from another. For part 16, if I want to simplify this, I'm just going to FOIL this out. So I'm going to have 2 times 2, which is 4. 2 times a negative 6i, which will be a minus 12i. That will give me a positive 12i. And then when I multiply these together, I'm going to have a negative 36i squared. Well, as a reminder, we know that I is the square root of negative 1. So if I square I, the squaring and the square root would undo each other. I'm left with just negative 1. So what I really have here is 4 minus 12i plus 12i. Well, that's going to cancel out. Those are additive inverses. Minus 36i squared, but remember, I squared is really a value of negative 1. So what I really have here is 4 plus 36, which has a value of 40. Now be careful. Because I use parentheses, I know that these two values are getting multiplied together even though I see that negative or minus sign, but this is a subtraction problem. So what I really have here is 4 minus 36 times a negative 1. If you didn't put these parentheses here, you'd have 4 minus 36 minus 1. So be careful with your parentheses so it's always clear what you're trying to communicate. So for number 17, when we simplify like an expression that's a rational expression that has complex in the numerator and the denominator, really we're just trying to get the complex number out of the denominator, that I term. The way we do this is by multiplying by the conjugate. So multiply by the conjugate. Well, the conjugate, oopsies, I'm sorry. Every complex number is going to come in a pair. So if you have 1 plus 2i, its pair or its conjugate is going to be 1 minus 2i. The conjugate for this numerator is going to be 3 minus 6i. You change the plus or minus sign of the I term. Well, if we're going to try to clear out the denominator from I terms, we're going to multiply by the conjugate of the denominator. So I'm going to multiply by 1 minus 2i, but if I'm going to multiply by something without changing its value, I need to multiply by a value of 1, okay? So now I'm going to start FOILing this out. I'm going to have 3 times 1, which is 3, minus 6i, plus 6i, oh, that worked out really nice, minus 12i squared, over 1 minus 2i, plus 2i minus 4i squared. Okay, well, let's look at a couple things real fast. You'll notice that I have these terms that are going to go away nicely. These terms are additive inverses. They'll go away nicely. So remember, this is really negative 1. So if I have a minus 12i squared, it's the same thing as having plus 12 because it says a value of negative 1. So 3 plus 12 is 15. Negative 4i squared is the same thing as adding 4 because I squared is negative 1. So 1 plus 4 is 5, so what I really have a value of is 3. Now this simplified really nicely. It's okay to still have an I term in the numerators. Ours just happen to simplify out there as well. But oftentimes your numerator will still have an I term left over. So now let's look at some complex and imaginary roots. We said a moment ago that they always come in pairs. So for instance, if 4i is a 0, we also know that negative 4i is a 0. We're going to write out polynomial expressions with the lowest degree with these possible zeros. So let's take a look at this. If I want my polynomial expression, we can call it f of x, we call it p of x, whatever we want. If I have a 0 of 1, I know that I have a factor of x minus 1. If I have a 0 of negative 2, I know I have a factor of x plus 2. If I have a 0 of 3i, that means I know I have a factor of x minus 3i. And then remember, imaginary roots always come in pairs. So I'm also going to have minus 3i. So even though we only saw 3 roots, I know I'm guaranteed at least a 4th root because this has a pair. Now I'm typically not going to let you leave it like this, so we're going to FOIL this out a bit. If I multiply this times this, I'll get x squared minus x plus 2x minus 2. If I FOIL out over here, I'll have an x squared minus 3ix plus 3ix, minus 9i squared. Let's think about what that really is. This is going to simplify down into x squared plus x minus 2. What I have here is really x squared. These terms are additive inverses. If I have a minus 9i squared, that's the same as having a plus 9. So now I can FOIL this out, or I'm really just going to distribute the x squared to all this and the 9 to all of this. So it's going to give me an x to the 4th plus x cubed minus 2x squared. Now I multiply out that 9 or distribute it out, plus 9x squared plus 9x minus 18. So that's going to leave me with so my function is going to be x to the 4th plus x cubed plus 9x squared plus 9x minus 18. Okay. See if we can do some more. I'm going to start you guys on number 18, but I'm actually going to have you see if you can finish and FOIL this out yourself. We're again doing polynomial equation of lowest degree with these zeros. Well, wait a minute. If we have zeros that are imaginary or complex, we know they come in a pair. So if I have 2 minus I, its conjugate will also be 1, which is 2 plus I. We just changed the sign of the I term. So if I have 4 plus I, I'm going to have 4 minus I. So if I start writing this out, here's what I have. I'm going to have x minus 2 minus I, and I'm going to have x minus 2 plus I times x minus 4 minus I times x minus 4 plus I. I'm going to FOIL out this first part. You guys are going to finish the rest of the problem for me. It does get a little bit gross and fun, but I think you guys can do it. When I FOIL these out, you'll notice that I actually, if I rewrite these slightly, have a difference of squares. And I don't know that my blue is showing up well, so let me see if this green will show up better. Pens keep rolling. Okay, when I FOIL this out, I don't really want to do x times all of these, 2 times all of these, I times all of these. So notice that I can regroup these as x minus 2 minus I and x minus 2 plus I. What that means is I really have a difference of squares, right? It's factored as a difference of squares, so I can rewrite this as, I want to make sure we do this right, x minus 2 squared minus I squared. Okay. Well, this is something I can FOIL out pretty nicely. X squared minus 4x plus 4 minus I squared, this is just really plus 1. So, and if I simplify this just a little bit more, I'll have squared minus 4x plus 5. So that's what this FOILs out into. See if you guys can do the same process by rewriting this as a difference of squares and getting it to this point. Then you're going to FOIL, or you're going to multiply these out, distribute to each other, see what you get for your final answer, okay? And I'll have a key up so you guys can check when you're done, okay? For these last two, we're going to use the 1 0 we have to find the remaining zeros. I'm going to do number 20, and you guys will do number 19 by yourself, okay? So for number 20, we have this 0. Well, we know from what we've seen before, if this is 1 0, then 1 minus I will be another one of my zeros. So I'm going to go through and see if I can turn this into some factors. So what I really have is I have x minus 1 plus I and x minus 1 minus I. Well, we just saw a minute ago that I can regroup this. So I have x minus 1 in both of these places. So I have something plus something, and then that same something minus that same something. Well, I can write that out really as x minus 1 squared minus I squared. It's a difference of squares. Okay, well, if I FOIL this out even a little bit more, x minus 1 squared will give me x squared minus 2x plus 1. This is going to give me a plus 1. So I really have an x squared plus 2x plus 2. Okay. Oh, I'm sorry, that's a negative 2x. Fix that real fast. Okay, well, we want to find all of the remaining zeros. Well, notice I already x squared, and this is x cubed. Well, one thing I could do is actually divide this into this to see what's remaining. So why don't we try that? Look at this, coming all back together to what we started class with. I hope I can fit this in. I'm going to use a sticky note if I can't. Okay, x squared goes into x cubed x times. If I FOIL or distribute that out, I'll get x cubed minus 2x squared plus 2x. Subtract this, it's going to be 0. Negative 5x squared plus this will be a negative 3x squared. This minus this will give me a plus 6x. And then I'm going to drop that. Well, this is looking nice because take a look. This x squared is going to go into that minus 3 times. I'm going to distribute that out. So that's going to give me a negative 3x squared, 6x, minus 6. And when I subtract that, I'll get left with 0. That fit very nicely. So it said find the remaining zeros. I'm just going to list them all out. So my first zero that I started with was 1 plus I. Then we said we know that 1 minus I will be a 0. And then 3, because my last factor was x minus 3, will be my last 0. Okay. There you go. You guys made it. That's our last set of the notes for the day.